Good morning everyone. Now I am going to discuss previous question paper about the mathematics 1, and it is the first student request. I am going to discuss R-13 paper. In that, in the previous classes I have discussed up to H. Here now I am going to discuss I and J problems. Define I is define unit impulse function. Define unit impulse function. Okay, here where we are defining that where we are doing, or when we are define that unit impulse function means it is occurred in the earthquake time, the large force acting on a very short period of time, then the two bodies are collision of two bodies. In such a cases we define this unit impulse function. This unit impulse function is a discontinuous function, and it is also called as, or it is also considered as a limiting form of a function. Okay, here define unit impulse function means in the fraction of seconds or in the fraction of some 2-3 seconds the earthquake is occurred. In such situations the earth is moving, and the force is acting, very large force is acting on the bodies and acting on the things in very short duration of the time. In such period the collision of the bodies are occurred. In such cases, the function is defined. In such situation, the unit impulse function can be defined. The unit impulse function can be defined as f epsilon of t minus a. It is equal to set of 0 for t is less than a and 1 by epsilon a is less than or equal to t is less than or equal to a plus epsilon, and it is 0 for t is greater than a plus epsilon. Okay, this function is called as, it is called as unit impulse function. Unit impulse function, and it is considered as, it is considered for limiting form of, is considered as limiting form of function, and it is discontinuous function, and it is discontinuous function. It is also defined in another way, that is f epsilon of t minus a is equal to set of 1 by epsilon for a is less than or equal to t is less than or equal to a plus epsilon, and 0 for other values. Okay, this is the same function, that unit impulse function can be defined in this way also, except this interval that function value is 1 by epsilon, and this is 1 by epsilon, it is epsilon of t minus a epsilon of t, and it is equal to x-axis is a time, here a and a plus epsilon. In this period only, that is the function value is 1 by epsilon. Okay, where we can, when we can define this unit impulse function means the large force is acting on a very short period, very short duration of the period, and the bodies are collision. In such situations, we define this unit impulse function, especially in the earthquake time. In such cases, this, in the short time, the function, it is a discontinuous function. Why? Because from here to here, that function is 0, and after a plus epsilon to the remaining values are also 0, except the limits from a to a plus epsilon, the function value is 1 by epsilon. Then this function is said to be, or this function is called as unit impulse function, and it is considered for the limiting form of the function, and it is a discontinuous function. This can be defined in another way also. Okay, this carries 2 marks. And next question. State and prove linear property of Laplace transforms. J. State and prove Laplace linear property of Laplace transforms. Laplace transforms. First, we can take the statement. The statement is, we can take two Laplace transforms if L of f of t is equal to f bar of s and L of g of t equal to g bar of s. Then Laplace transform of linear form, that is linear property, means c1 f of t plus c2 g of t is equal to c1 L of f of t plus c2 L of g of t. This is equal to c1 f bar of s plus c2 g bar of s. Here it is a statement. We can take what the transformations. Let L of f of t is equal to f bar of s equal to integral 0 to infinity e power minus st dt. And also L of g of t equal to g bar of s, it is equal to integral 0 to infinity e power minus st f of t dt minus st g of t dt. Here we can take the linear property. Take linear property with two functions f of t and g of t is c1 f of t plus c2 g of t, where c1 and c2 are arbitrary constants. Here take Laplace transform of this linear property. L of c1 f of t plus c2 g of t is equal to integral 0 to infinity e power minus st c1 f of t plus c2 g of t into dt, that is equal to integral 0 to infinity e power minus st c1 f of t dt plus integral 0 to infinity e power minus st c2 g of t dt. c1 and c2 are the constants, take right outside. c1 integral 0 to infinity e power minus st f of t dt plus c2 integral 0 to infinity e power minus st g of t dt. This is equal to c1, it is the Laplace transform of the function f of t, plus c2 Laplace transform of g of t. It is also equal to c1 f bar of s plus c2 g bar of s. This is a linear property with the statement and proof. The statement is we can take two linear Laplace transforms, that is L of f of t and L of g of t. And linear property means the combination of the two functions with the two constants, arbitrary constants, that is c1 f of t plus c2 g of t, that is a linear property. We can take that linear property in the Laplace transforms. The function, that is L of c1 f of t plus c2 g of t is equal to c1 L of f of t plus c2 Laplace transform of g of t is equal to c1 f bar of s plus c2 g bar of s. Okay, this is the statement and proof of the linear property of Laplace transforms. Okay, the short questions are over. Part A is over up to this. Here, a first question from A to J, total marks 25. It's completed with the related units. Total from the 5 units, each unit carries 5 marks, and from that the given questions are 2 questions in individual unit. Okay, if you like this video, please subscribe my channel and share to your friends. And if you have any doubt, you ask me, I will clear my level best. Okay, thank you.